Everyone, and welcome to lesson 7.5, day 1. Today we are going to talk about the triangle bisector theorem and a little bit about the side splitters theorem. Now, the angle bisector theorem in a triangle states that if a ray bisects a triangle, then it divides the opposite side of that triangle into segments that are proportional. So in this particular example, A is going to be proportional to B, the same way C is proportional to D. So you can set up a proportion and solve for those missing side lengths. So for the first example, if we are looking to solve for that missing question mark length, we know that with that bisected angle, 6 is going to be proportional to our missing side length, the same way that 2 is proportional to 3. Now be careful to make sure that you are going, for instance, I went left to right, then left to right to set up those two proportions correctly. Cross multiply and solve, we get 2 times x equals 6 times 3. So 2x equals 18, and when we divide by 2, our missing side length is 9. The second one is here for you to try to find this missing side length. Down below, we have a couple more numerical examples. This next one is asking us to solve for officially this missing total side of our triangle. But what we can do in order to find that is start by actually solving for this little missing piece similar to up above. So we would have 20 to 16 side to side, the same way that we could then have 10 to x. So again, notice I went top to bottom, top to bottom. Cross multiply and solve, we have 20 times x and then 16 times 10, which is 160. Divide both sides by the 20. X this time is going to equal 8. Now we need to be careful again, make sure we're answering the final question. This piece is 8, but we want our final answer to be that whole segment. So the question mark is actually going to be 10 plus 8 for a total length of 18. In example 3, they actually gave us the full side length here is 12. We know this little baby piece is 4, which if we take 12 minus 4, this missing piece is 8. Now this allows us to set it up so that we could take side to side. So 10 over that missing length is going to equal 8 over 4. Again, top to bottom, top to bottom. Cross multiply and solve, 8 times x equals 10 times 4. When we divide 40 by 8, x is 5. And this time that is our missing segment length we are looking for. Try the last one on your own. Again, you're going to want to solve for this missing piece first before you find your final answer. Now, as we flip to the back, we also can use the triangle bisector theorem in order to solve for pieces of x. So for instance, we could say 4 to 2 is going to be proportional to 2 to 2x minus 9. And a reminder, when we're solving on these, you want to make sure that when we set this up, we have 4 times 2x minus 9. We again want to use parentheses to make sure that we distribute correctly as we begin solving. So 8x minus 36 equals 2 times 2, which is 4. Add the 36 to both sides. We end up with 40. And then divide by 8, x equals 5. Similar to some of the examples on the first page, again, we're given this whole side length is 12. Part of it is 4, which means this remaining piece here is 8. And now we can set this up side to side equals the base piece to the base piece. So we have x minus 3 to 10 equals 4 over 8. Cross multiply and solve. We have 8 times the x minus 3 equals 10 times 4. Distribute and then solve. We end up adding the 24 to both sides. 8x equals 64. Divide by 8 to get our x value, which also is 8. Okay? So use example 5 to help you then try the next one on your own. All right, the final little piece to today's lesson is going to introduce to us the idea of the side splitter theorem. And again, setting up proportions. So what the side splitter theorem says is if we have one parallel line that is parallel to the side of a triangle and it intersects the other two sides, it divides those two sides proportionally. So A to M over M to B is going to equal A to N over N to C. Okay, and by a corollary to that, that also will work for intersecting parallel lines as well. These little sections X over Y is going to equal C over E. Again, allows us to cross multiply and solve those proportions. So for instance, in number 6, we have 4 over 3. It doesn't matter if we do 4 over 3, or we could have done 3 over 4. That's going to equal, then if we went top to bottom here, we'd have to go top, the side across from that, to bottom here. So X over 6. Cross multiply and solve, we have 3 times X equals 4 times 6, which is 24, and divide by the 24. Our missing side length is 8 this time. Now notice in our second example, they didn't give us the small piece here or this small piece, but they did give us the large piece. So if we are looking for this piece here, we can use that corresponding value to it. So we have X and then we have 4. We can also then use these larger side lengths. So for instance, then 18, and this whole side, 4 plus 8 would be 12. So that proportion is also something you may end up using. So we cross multiply and solve. 12 times X equals 4 times 18. 4 times 18 is 72. And 72 divided by 12 is 6. Last example together also involves a little bit of algebra at times. Again, on this example up above here, we went 4 over 3. You could also do 6 over 9. I'm going to choose to start this one. I'm going to say 9 over 6 is going to equal, if I started with 9, I have to start with X plus 8 over 10. Cross multiply and solve. We end up with 6 times X plus 8 equals 9 times 10. Distribute, we have 6x plus 48 equals 90. Subtract the 48 from both sides. 90 minus 48 is 42. And then last but not least, divide 42 by 6. We get x to be 7. The final example is here for you to use the side splitter theorem corollary to solve for x. Thanks everyone for watching, and we'll work more with these in class.